Equipment Test Facility. Everything's an acronym around here. We call it the LETF, so you'll hear that a lot today, I'm sure. LETF, Launch Equipment Test Facility. Give you a little. What we're going to do here is I'm just going to give you a little bit of history, maybe a little background on what we do here at the LETF. So when you're out here talking to some of the other people, it'll kind of maybe all tie things together for you. The LETF was actually first built back in the 70s to support space shuttle. And for the last 8-9 years, we've gone through a major refurbishment. A lot of equipment got very old, 40, 50 years old technology. So we've gone through a lot of refurbishment upgrades to get prepared for what we're doing now, which is testing for the SLS heavy lift vehicle. The main purpose of the LETF is to perform what we call qualification, full-scale qualification testing for ground support equipment. So what's ground support equipment? Ground support equipment is anything that's used here to support the launch. It doesn't fly with the vehicle, it stays on the ground. So, and some of the critical pieces that we test are called umbilicals or access arms. These are things that actually touch the vehicle and usually separate right before launch. And if you look back at some of the old footage of like the Apollo program, that was a real good example. You'll see all those arms disconnect and swing out of the way. Those are the things that we test for. You say, well, you know, why are you testing them? That's another good question. So NASA goes through several phases for these umbilicals. And here at KSE, we are responsible for ground support equipment and everything at the launch pad and the mobile launcher. Well, we go through a design phase, of course. NASA designs most of the umbilicals and the ground support equipment with help from ESC, with the engineering services contract. We have a design engineering group that works with NASA to do the designs. And once the designs are complete, they get sent out for fabrication to usually a local kind of subcontractor. And then the next step is they come here. And once they come here, we instrument them. We put strain gauges, load cells, temperature probes, whatever NASA is asking us to do. And that's usually done here in this high bay. So you'll see, you know, when you have this big high bay floor, and usually the arms come in here first, they get instrumented. Once they get instrumented, they go out and they get put on one of the towers. And when you go out to see the VMSs, the vehicle motion simulators, you'll see, you'll get to actually see if you have something right now.
So our whole job here is to kind of simulate the mobile launcher platform and kind of a portion of the launch environment these umbilical arms will see. We're kind of a test like you fly concept here. So you know, all the interfaces to these umbilical arms, whether it's electrical, cryogenic, mechanical, whatever it is, we'll simulate that here, and we'll test the arm just like it's going to operate when it's out in the launch environment. And that includes rollout to the pad, motions on the pad while the vehicle is just kind of moving around in the wind or it's a windy state, all the way up to about the first half a second of launch. So we can actually test the separation mechanisms as well.
So what we're trying to do here is, because manned vehicle, we are here to make sure that all the alarms work properly like they were designed. The biggest thing is you're going to disconnect and not cause any damage to the vehicle. And one of the other things that we can do here is, everything you know, NASA has redundancy because it's a manned vehicle. We have primary disconnects where things disconnect like they're supposed to, and then we can cause that primary to fail here so that we can check out the secondary disconnects and verify that the redundant systems all work. And so when it leaves here and goes to the mobile launcher, we know it's going to work properly and the vehicle will fly without damage. So that's the main thing, and that is our main purpose here. We have several shops support the testing. We do a lot of fabrication efforts here, and the reason we have that is if you're in the middle of the test, the cable or something breaks, we got a guy that can go in and make one in about 10 minutes and get a new cable, and we're back into testing. We have a machine shop, a weld shop. Pretty much we're a self-contained area where we can do just about anything without outside support, because usually if you're in the middle of a test, you don't have time to go and sub something out, get something built, buy something specialty. Most everything here is one of a kind. And we have about 50 people that work here. We have about 10 engineers or so, about 20, 30 techs, and support people, managers, schedulers, those kind of things like that. And if you walk around, you can take a couple minutes if you like and look at some of the posters we have. It describes some of the capabilities we have here. They said one of our biggest things that we actually do here, our product, is data. So it's telling you how we instrument things. When we get done, we deliver the arm to NASA. We also give them the data. And the data from the testing is what they use to verify that it operated properly. And it's proof for use of the mobile launcher. So, any questions?
This building seems pretty empty right now, and I can imagine when you bring in an arm, when you start testing, there's a lot of equipment that you have to bring here, because you are testing some mechanical moves, you are collecting data, so I see a lot of, like a doctor and operating on it, a lot of equipment around it, but I don't see anything in here, so I assume that a lot of stuff is brought in.
If you would have been here maybe a month ago, it had an arm in here. So like you see the arms that are hanging out on the towers now, one of them was in here not too long ago, and like I said, this is a good environment to do the instrumenting. We could do it outside, but it's not a very good environment outside to be putting all the strain gauges and everything on. Plus, what's good about this high bay, we've used it for a lot of other things. We do some prototype testing in here. If there's things that smaller things you want to test, components, we do component testing as well. We don't always do the full scale 100%. We might do a section of that arm back in the prototyping stage, back in the design, when we were talking about design earlier. We'll do some prototype testing. This is a good area to do it in because you don't have to worry about the weather. And if we can get it inside here, we have some simulators like the component liftoff simulator behind me that does smaller liftoffs. They're not like the 6 degree of freedom, large scale motion simulators that we have out in the field. But we can do some smaller tests in here. We can do some assembly in here. It's a good place to do assembly. Sometimes these arms show up, they may not be put together completely. So they'll show up, pieces will show up, and this is where we do a lot of the assembly and everything just to get it all prepared to take outside and hang up. So hopefully I answered your question.
Thank you so much.
Yeah,